Hello and welcome to the video walkthrough for Metaboverse. Metaboverse is a user-friendly tool that enables pattern analysis of your data on the metabolic networks of around 90 organisms currently, with updates planned for the near future to enable the analysis of more organisms from other databases. Metaboverse automatically and rapidly identifies a variety of regulatory and other patterns in your data and provides additional visualization tools to further explore these patterns. The first page we'll see when we open the Metaboverse app is this home page here, where if we have already analyzed a data set and curated that Metaboverse file, we can load that file here and pick up where we left off with our previous analysis. With any curated Metaboverse file, we can also select the Session Data tab and view any pertinent information for this data set. If we are analyzing a data set for the first time, we can skip the home page. And if we've previously analyzed data for the same organism, we can upload that file here, which will end in .mvdb, or we can select the organism from the drop-down here. For the dataset we'll be using for this example, we're going to select Saccharomyces cerevisiae. We should also provide an output file name. Here we can call this test output, or whatever you would like to call your file, followed by the file extension .mvrs. At this point, we can continue on to the next step. You'll notice here for this video, we have this feature under development where eventually you will be able to provide network curations for other organisms. However, this is still currently under development, and once this feature is fully available, this note will be removed. Next, we can provide all of the input data and any other experimental variables that we need to analyze the data set. The input data should be formatted in one of the following ways. For any combination of transcriptomics, proteomics, and/or metabolomics, if you're dealing with a single condition, you would want to provide log2 fold changes and p-values or corrected p-values for each measurement. You'll see here that the first column would be the gene names or protein names or metabolite names. The second column would be labeled something like fold change, followed by those values. And then the third column would be labeled p-value, FDR, corrected p-value, with the appropriate values. An important note is that you should provide the appropriate p-value correction for the data type. For example, in the case of transcriptomics, there are various packages available that provide thorough p-value correction, which would be appropriate in this case. For a time course or multi-condition data set, we can use a combination of a single time point. In this case, we have one proteomics time point paired with fold changes in p-values for each time point in the metabolomics, or we could have matched proteomics and metabolomics time points. For a data set with multiple time points or multiple conditions, you should follow the same formatting as above, but you'll have repeating fold changes and p-values for each time point or condition. These tables should be output as a tab delimited file ending in the file suffix .txt. In Excel, you can do this when exporting the file by selecting the tab delimited option along with the file name. For this example, we'll use the test data set provided with every release of Metaboverse. In this case, we will be providing transcriptomics, proteomics, and metabolomics data for this experiment. I'm going to provide an experiment name, in this case, yeast time course. And as this is a time course, we'll select the time course experiment type along with the labels for each time point being analyzed. Once we have provided these experimental parameters, we can begin to process the data set and curate the model. For organisms with smaller annotations for their networks, this may only take 5 to 10 minutes depending on your internet connection, as is often the case with yeast data sets. However, if you are analyzing an organism with a more thorough annotation, such as humans, this step could take 20 to 30 minutes, again, depending on internet connection. Metaboverse should continue working unless it provides an error message. However, if you notice that Metaboverse has paused on a certain percent in the progress bar for more than 20 minutes, a silent error may have occurred, and you can either try rerunning the dataset or you can submit an issue to the GitHub page. Once your data has finished processing, you'll see a completed progress bar along with buttons for the different analysis options. We can start by looking at the pattern analysis. Here, Metaboverse will search the network for interesting patterns within your data. On the left side, you'll see a variety of different boxes that provide different pattern options to search. You can view a brief description of each of these by hovering over that button, and you can change the threshold by changing this number here. Once you select a pattern type to analyze, you'll see a listing of all the different reactions that were identified. A green background means that both sides of the reaction had significant measurements that contributed to that pattern. A yellow background indicates that only one side had significant measurements. And a gray background indicates that neither side had significant measurements. These categories of patterns will also be sorted by the magnitude of the differences between the inputs and the outputs. We can select one of these reactions, look at the pathways that this reaction is involved in, and also look at a list of all of the patterns available within that pathway. For time course and multi-condition data, we can look at the behavior of this reaction's components across all the different time points. If we want to look at reaction patterns at a different time point, we can toggle the slide bar to that time point, which will then be populated by the different reaction patterns available at this time point. We can also tell Metaboverse to find us all reaction patterns at the 60-minute time point, but that are not found at the 0-minute time point. We can also look at the key here to look at the different color codings and pattern codings for the reactions. Next, if we want to generally explore different pathways, we can select the Explore button, select a super pathway such as metabolism, and then select a more specific pathway. In this case, we can look at the citric acid cycle. For time course and multi-condition experiments, we can look at how these behaviors and reaction patterns change. The reactions with an identified pattern will be differentiated by this purple outlined star. Shaded regions indicate different cellular compartments, And we can view the key for this by hovering over this icon. We can also view the shape and color code legend by hovering over this icon. If, for example, we wanted to turn the compartment shading off, we can select the appropriate button. And any of these other options, we can hover over that option and view a short description of what that button will do. If we wanted to explore the upstream and downstream reactions that, say, citrate is involved in across all of the pathways within the organism and not just within the citric acid cycle, we could double click this node and look at the nearest neighbors or the nearest reactions that this metabolite is participating in. If we wanted to view all of the different synonyms for a metabolite or protein, we can single click on that metabolite node and have a list of the different synonyms on the bottom left here. And then if we click on a reaction, we will be provided with that reaction name as well as a brief description of that reaction. If we are viewing a section of the network that seems to be a little bit too cluttered, we can drag any of these nodes to help reorganize the network and try to organize the layout of this pathway. Finally, if you would like a quick snapshot of all the perturbations or patterns within a given superpathway, we can click this Perturbation Network Exploration button and select the superpathway of interest. For larger collections of perturbed reactions, the given superpathway may take some time to render, but once it's rendered, we can zoom in and out and view the total extent of perturbation within the superpathway. Here we can get a quick snapshot of everything that's changing and zoom in on particular features to see what's going on and see if there's any particular pattern that we're interested in. Within this analysis option, any two reactions that are next to each other connected will automatically connect in this view. And any reactions that are not connected to a neighboring perturbed reaction will appear as these isolated reactions. If you have any questions when using Metaboverse, you can contact us and submit an issue on the Issues forum, or join our discussion forum. We hope you enjoy Metaboverse and are able to find interesting patterns and make new discoveries from your data using this tool.